Hey, this is Stereo Police. Today I just kind of on a whim decided to make another video about the TEAC NT-503, and one of the main reasons is I did that DAC review, the Great DAC Off series of videos a little while back, and the shit Bifrost multi-bit won the overall competition based on my perception of sound, and that was the only criteria for that, was sound, not features, nothing else, just sound. And I ultimately preferred the shit. However, the TEAC was a very close second, and following that series of videos, I made a bunch of other videos with various reviews of amplifiers, and I can't remember. I never remember all the videos I make, but my main system continued to include the TEAC, and the shit was nowhere to be found. And I kept receiving a lot of comments. What happened to the shit? What happened to the shit? Why, I thought that won. Well, it ultimately won based on sound. I had a preference towards that sound. However, the TEAC is the one that I stuck with for my main system. And my main system is that system that's featured in the other videos, and includes the Klipsch Forte 3s and the Yamaha AS 1100. And like any audiophile, I'm back and forth with equipment. I'm substituting in and out this and that and this and that, but I've settled on my main system. It's the Klipsch Forte 3s, it's this TEAC NT-503, and the Yamaha AS 1100 integrated amplifier. And I have a turntable that I want to put out there, but I haven't, that's still up on a shelf. But anyway, so why, the question again is, why do you have the TEAC in the system? And the answer is, number one, it sounds fantastic. It's great. It actually beat out, in my perception, it beat out the benchmark DAC 3 in terms of sound, and the benchmark was more than twice the price. But the other reason is the features of the TEAC. So I thought I'd make a follow-up video about the TEAC. I never really, my reviews were really based on the sound, and I never really got into the features that much. So since I've been living with the TEAC, I really love it. And I thought I'd make a follow-up video about the features, what it has to offer, some of the things that I really like about it. And then let's actually, if I can, I want to open this thing up, because this is one thing. Let me see, there looks like they're Allen screws. Let's get a look up inside of it, but let me just start out by showing you the features, the exterior, the buttons and knobs and connectors, and then I want to discuss some of the features that on paper that I like about it, and I printed out a few things to talk about. I like the design of it, and then let's open it up, look at it, and then I want to hook it up and run through the menu with you and show you the menu. But I highly recommend this. And let me start out by saying that the shit was roughly $600, the Bifrost multi-bit. The TEAC is roughly $1,000, $999. So the TEAC is about $400 more, and it's worth every penny and then some. In fact, if you were to tell me that benchmark DAC 3 was, I know that's $2,000. Is that what it was, 2,000? It's not 3,000. I don't remember. I think it was $2,000. And knowing, we know that the TEAC is about $1,000, but if you were to tell me that both the benchmark and the TEAC were each $2,000, I would still have purchased the TEAC over the benchmark, even at $2,000. I'm glad it wasn't, but that's how good it is, and this thing has been 100% reliable. I have used it with Bluetooth extensively for background listening, YouTube, things like that when I have friends over. you know, all the friends want to connect to, you know, YouTube and stream, look at videos and stream to the, you know, and this has a great, let me turn this over. Here's the Bluetooth. Down there is the Bluetooth antenna, and it has a great Bluetooth system in it. Fantastic. Very few, if ever any, interruptions. I have used, well, let me start from the front. Okay, so one of the features I like about it is it can be used as a, well, let me start out with the cosmetics. Okay, it's all aluminum, it's all brushed aluminum. Every panel is metal. It looks super high quality. It is well built. All the lines, everything is, you know, super high quality. It instills confidence. It instills quality. The input selector button is knurled. I think it's a plastic button, but it feels good. It's not wobbly. The volume control button has a nice silky feel. Now you don't have to use this. There's an internal setting that you can set this to line level out fixed, and this becomes useless. But if you want to use this as a preamp, or for some reason you want to raise or lower the gain of the output of the analog outputs, you can select that, and you can use this as a preamp as well. And it has a nice velvety, smooth feel to it. Again, instills quality and confidence. Buttons, all nice. Has a headphone output. I have not listened to the headphones through this. I have no idea what that sounds like. It has one front USB-A type connector for plugging in devices if you want to from the front. That makes it really convenient. It also has a USB style connector on the back. There's the menu button. I'll go through that when I hook it up. The power switch, nice feel to it. I believe that's an aluminum switch. And let me turn this around, see if I can do it with one hand here. There we go. So here's the back. It has XLR for balanced, and it's truly balanced. And that's one thing I miss about, I have that Yamaha AS1100 integrated. That's the one feature the AS1100 didn't have, was balanced inputs. I would have had to spend a little more to get that. But it has balanced, gold plated. Here's your standard RCAs for unbalanced outputs. If I said inputs, I meant outputs. Ethernet, which I use. Here's the USB B style connection, which I use. I'll show you that I'm using a laptop computer, and I have some FLAC files, high res, and I'll go over that when I get this hooked up. Here's the Bluetooth antenna. You can provide an external clock. I haven't done that. In fact, I don't even know what that's all about. I'm fairly new to the high-res business. I have used the coaxial input. I used that for my Sonos, but I no longer use Sonos. Optical, which I have not used yet, and of course the power receptacle. Again, all super high quality, looks nice. Not that anyone's looking at the back of it, but all of the jacks, connectors, none of them are wobbly. They're all they're all solid. Good quality stuff, gold plated. Okay, so let me hit pause and pop this camera on a tripod and cover some features on paper that I really like about this, and then go get it hooked up and show you. Well, I'll do some high-res files and show you what the display panel. Oh, and go through the menu system too, which is really interesting. Okay, so here's the paper portion of the review here, but I think it's worth going through. Again, the shit was $600 and the TEAC is $900. Well, and I'm sticking with the TEAC. Printed this out in low quality, but this is not really for you to read, but for me to remember what I wanted to say more than anything else. And I am going to need some glasses. Hold on. Okay, so the heart of this DAC is the Verida AK4490, which is one of the latest and greatest Delta Sigma DACs on the market. Very good. And this DAC has no problem with all the common high-res formats that are out there right now. It handles them all with ease. And I have various high-res files that I'm playing and through a laptop through the USB connector in the back, and never had an issue. Sounds fantastic. The high-res is just awesome. So, you know, all your various sampling rates and streaming rates, no issues whatsoever. It can handle them natively. Now, just FYI, the Verida DAC that it uses, this is just a block diagram. I'm always interested in block diagrams. I'm not going to go through it thoroughly here, but basically, the two main types of data it can accept are PCM or DSD. It can take DSD natively. And right now I'm streaming FLAC files, which is PCM data, pulse code modulation. But ultimately, everything gets D to A converted using a Delta Sigma modulator, which is just fine. These are the lowest noise modulators available, far lower noise and even distortion, but far lower noise than you could get out of an old style R2R ladder. Not to say that R2R ladders aren't good. And this interpolator here, and you'll see this on the front panel, allows for PCM data to be upsampled if you choose, prior to it going into the Delta Sigma. And then the from the Delta Sigma you go through some selectable digital filters here before it gets passed out where your final analog filter would be. That would be designed and implemented by whoever is implementing this DAC. The TEAC allows for, and this will be on the when I demonstrate the menu system, it allows for you, the user, to select not only, as I mentioned before, you can upsample PCM if you want to various different sampling rates if you choose to, but it allows you to select different filters. Now these filters are filters that are native to the DAC itself, and native to the Verida and these output modules, and TEAC has implemented that. They didn't have to do that, but they've set that up so that the user can pick which one of these filters, sharp or slow, or short delay filters. And so the finite impulse response, sharp and slow. Where's a pen? I didn't want to get into this, and I'm not going to, but basically sharp and slow are just like, you know, when you look at a filter cutoff, these are low pass filters. A sharp filter is, you know, just like that, and a slow filter the response will more slowly roll off like that. And there are benefits to each. You can look those up on the web. And this is a short delay filter. So this is a different type of filter that has a shorter time delay. And you can do a sharp and slow. And again, these characteristics you can look up, or you can decide not to use any of these filters. So, you know, a user could go through these filters on the TEAC and you know, back and forth and just see what sounds better. And there's nothing wrong with that. You know, go with what sound. You could look up the characteristics on the web as to what they actually do. They each one has a benefit and a drawback, like everything else. It's all a compromise. But generally, I listen without any of these things hooked up, and it's just basically through the analog filter that's in the TEAC. But I've gone through a few of them, and I'm hard pressed to tell the difference. And then if you're streaming native DSD, then you can choose the cutoff frequency, 50 kilohertz or 150 kilohertz. I don't know that you'd be able to hear a difference. But it's there. Maybe there's a psychological aspect to it. Okay, another thing I like about the TEAC is it is a true dual mono design. Okay, both the left and the right channels have their own power supplies, their own transformers, their own DAC chips, and their own circuit paths. They're separated. They're completely separate. That is always a good sign of quality. Now, this is, not that I'm going to go into this in much detail, but this is the block diagram from the service manual of the TEAC. And basically, just quickly tracing through here, you have all your various inputs over here. Here's your dual transformers. They're toroidal transformers too, excellent. And so it starts out from the beginning with separate power supplies for the left and the right channels, and then there's the right channel, there's the left channel. Okay, so top and bottom. And basically the first thing, I mean, there's a little processing that needs to be done with the various types of inputs, whether it's a USB or optical or coax or what have you. But beyond that, we go into our completely separate left and right channels, and we start out right here. This is an indication of the, got to look at it closely. Yes, that's the Verita. Yep, so I got to look. It's blurry too. That's the DAC chip. So our signals ultimately filter through some processing, and they go into our left and right DACs. I'll just look at one channel right now. So we begin with our DAC. And the DAC may or may not, depending on what you select on the TEAC, may or may not have some digital filter hooked up in line. But ultimately, once we leave the DAC, we go through our standard and traditional analog low-pass filters on the output, indicated right here by these op-amp looking things. And then from this point on, we have separate balanced amplification. So one channel is going to be sort of each channel is going to be an opposite phase of the other channel, and that's basically a balanced configuration. From there on out, we're all balanced. And then from here we go into this guy here, and I looked him up, and he is an electronic volume control. So that's a chip that is an electronic volume control, and that's what you're going to be controlling when if you choose to use that front volume control, and it's in line even if you don't use it. When you set that front volume control to just 0 dB fixed output, the signal is still going through this. It's just that you can't control it anymore, and this is set to a particular position. So we're still going through this chip, and then we get to our output stage, which is what TEAC refers to as the quad enhanced current output buffer circuits. And this is where TEAC parts ways in a good way with some traditional DAC manufacturers. A lot of traditional DAC manufacturers will use right here as an output buffer an op-amp. An evil, filthy, disgusting, terrible, horrible op-amp. And TEAC has chosen as their output buffer, and this is the last, this is basically the current amplification. This is the last thing that the signal sees before it hits your RCA or balanced outputs. And TEAC has a really interesting design, and it is again, they call it balanced quad enhanced current output buffers. Interestingly, they show on their website a depiction that looks like this, and it kind of depicts a first. Okay, again, this is your every channel, one channel, it's balanced going through the amplifiers here. So you have opposite phase signals, passing through each. It shows a depiction of an op-amp followed by some discrete that looks like bipolar junction transistors in a push-pull arrangement. And that's not exactly what's going on, and I'm not going to get into too much detail, but I did do a no bullshit check by following the schematics, and part of it's correct, part of it's not correct. And again, I'm not going to get too technical on that, but I will describe what is a little bit different. So, you know, again, our outputs here go to either our RCA or our balanced XLR jack. Okay, so let's take a look. And what I have here is I have a depiction, again, a close-up of the block diagram we were just looking at from the service manual, and just so you can see, there's the Akita, if I said Akita, the Verita DAC, followed by our low-pass filters, followed by our electronic volume control, followed by our buffers, which they are discrete. Okay, there's no doubt about that. TEAC wasn't lying, but they're not BJTs in a push-pull arrangement. So now this is really small, and this is where I could talk a long time, but I'm not. But basically, that whole, this little thing right here that looks like an op amp is an op amp, and it starts over here. And the electronic volume control sends the signal directly to this op amp circuit, which increases the voltage, and then the output, we have a push-pull. We do have a push-pull. Maybe that's what they're showing. We do have a push-pull BJT arrangement right here. Now that I look at it, I'll tell you why I was a little goofed up by it before. But yeah, okay, there's our push-pull. So there is an op amp feeding a push-pull BJT arrangement right there. Okay, but interestingly, the signal doesn't. There's something else that it goes through, and it goes through these little blocks right here, and they drew them as blocks, but I looked up the part number, and it's actually, each one of these blocks is a MOSFET. So we have an output, another output buffer of a MOSFET, and that MOSFET device, when I looked up here it is right here, and there's the schematics for them right there. So once we leave this op amp followed by push-pull BJTs, we go through these MOSFETs, and they're hooked up in a really strange way. They're actually hooked up as, and I'm not going to get into too much detail here, but they're hooked up each channel. Okay, the signal actually comes in here, okay, from the op amp by BJT push-pull, and goes into the drain of one of those two MOSFETs. The source, let me just follow the channel. It goes into the drain, comes out the source, goes to the source of another one, out the drain, and then out towards the out towards the RCA or the XLR. The gates of both MOSFETs are hooked up to this little transistorized transistor circuit here, and the input of that comes from a shift register. So that basically just turns, the shift register just turns those gates on or off. So that's just a way of actually switching on the outputs. So this is a common gate configuration. It's ultimately a current buffer. It's the final buffer that the signal sees, and that's all I'm going to get into. Common gate configurations and current buffering. So that little diagram that, I'm getting way too technical here, I'm going to move on. That little diagram that TEAC shows is not exactly totally accurate, because there's something else. There's another buffer out here that are actually MOSFETs in a common gate configuration. But that's neither here nor there. It's the we do have some discrete circuitry there, but there are op amps involved. But it's nice that their final output current amplification is done with discrete devices, rather than just sticking with an op amp by itself. That's what the shit uses. The Bifrost multibit uses an op amp. So it's nice that they took the time to design something good, and it sounds really, really good. So I'm sure that has something to do with it. Now, I'm rambling here. Let me get to the final features that I really like, and then we'll hook this thing on. Let's open it up. So another thing I like is it has toroidal transformers, which are ultra low noise and much more costly transformers than your standard regular kind of transformers, you know, the El Cheapos, box transformers. Iron core transformers. These toroidal transformers are more expensive, but they're much higher quality and much lower noise, and that's important with these low signals that exist inside of a DAC. So I like that feature. The connectivity is awesome on the TEAC. You can connect just about any way you can think of. I'm running a PC through a USB. Playing my FLAC files, high res. I often Bluetooth when, you know, especially when friends are over and we're listening to YouTube. You know, it's not critical listening session. You just want to hear some music. It sounds great. Again, optical. You can put a flash drive on that front USB if you wanted to. It'll play files. You've got your coax. Everything you could ask for, I believe. I'm not sure there's another kind of connection you could possibly ask for. If there is, I'm not thinking of it right now. So connectivity is great. So far, every connection I've used has worked flawlessly. Again, the Bluetooth is great. It's nice that it's built in. You don't have to buy any. Some DACs, you have to buy some extra thing to plug into it for Bluetooth. Supports full high res, and it's got apps for Spotify and Slack or Deezer. What's that, TuneLine? I don't know what all. I use Spotify, and as a Spotify premium member, I stream at their highest resolution right from my tablet, and it's not using Bluetooth. The tablet is controlling the TEAC, and the TEAC is getting the signal from the Cat5 directly from the web. So we're avoiding Bluetooth crap. Okay, that's that. Enough of that. I'm just curious. I'm going to go ahead and remove the top, and let's get a look at the inside of this thing. And I'm not going to touch anything. I don't want to destroy. I'm looking at nothing here. Destroy anything with static electricity. Although I do have where's my thing here? I do have my static bracelet that I should be wearing, especially when I open it up. But all right, see if we can open this up. All right, well, that wasn't exactly easy, but I took this. When I loosened this top panel here, I still couldn't get it off because one of the two rack handles on the side had to come off because it's kind of wedged in between the two, but there it is. And you know, this being a DAC, you're going to see a lot of chips, but just looking around, okay, we're looking at the front right now. That's the display panel. On the left there is the electronic the electronic volume control knob, and it is all, you know, as expected with TEAC. Very high quality, beautifully laid out, beautifully constructed. There are the two transformers, so I wanted to do our no bullshit test to make sure they're toroidal transformers, and there they are, both of them in all their glory. You know, not that it's necessary to take that as the power supply board right there, kind of upside down. It's another power supply, and there's a big chip down there. I wonder where those I think, oh, I don't know what's buried under there. I was hoping to see the output circuitry, you know, the buffers, but I think they're buried. I think they're buried under this board right there, and I'm damn sure not taking that off. In fact, I don't want to touch anything in there, just for fear of static electricity zapping one of these chips. looking down. I can't see down there, but I think the analog circuitry is down there. Although there are some transistors right there, if you see those 4 larger size transistors in a row. Q534. I'm probably the only person interested in this, but Q534. Well, those output MOSFETs right there that are circled at Q542. Those are Q540 somethings. So I'm not exactly sure, and I don't really need to know that much, but there are 4 discrete transistors down there. Not sure where those where those are in the schematic, but anyway, the point being here is not to trace the circuitry, it's just to look at the quality, and it is very, very nice, as I fully expected. Large filter caps right there for the power supply. 4700 microfarad, 35 volt. KMG. And I'm just looking at the circuitry on the front. Okay, well, now that we've seen that, I'm always curious as to what's on the inside of things. That's how I started out in electronics, you know, when I was a kid. It was just every time I got something, I'd turn it on, whether it's a portable radio or whatever it is, turn it on, listen to it for a little while, and I liked it, and then a day later I'd have to open it up, and half the time I'd open it up to the point where I couldn't get it back together again, and there's another radio destroyed. It used to really piss off my parents. And I still like doing it. And I'm an amplifier. Throughout my life, I've designed and built speakers and amplifiers and preamps from scratch. But when I went to college in the late '80s and early '90s, and digital was not, we had CD players, but things weren't that sophisticated yet. And digital circuitry and integrated circuits were just sort of coming of age. I mean, major league integrated circuits and digital signal processing was just sort of coming of age. So I never really studied it. And since college, I just haven't had that much interest in it because my interest has always been more analog. So looking at something like this, with all the ICs and the chips and the surface mount technology and all that, there's still a mystery factor to me, which sort of brings back that magic. When I was a kid, there's always a certain amount of magic in things that where you don't know how they work. I still kind of have that a little bit with respect to digital signal processing. It's just not my thing. I've never wanted to study it, although I might one day. I don't know. I have studied how delta sigma modulators work, and R2R ladders. Those are interesting, but all the digital filtering and the DSP stuff is just still, to me, is just still somewhat kind of magic. And I don't know if I want to get into that one day, but I'm certainly not going to build and design digital equipment. So I don't, I'm still really into amps and preamps, power amps, and that sort of thing. But I'm on a tangent here, so I'll tell you what. We get this thing back together again and hook her up to the stereo, and we'll go through the menu system and the various functions of it, and I'll show you that aspect, which is the user interface aspect of this. I really, really like. And that's another reason why this TEAC is a keeper, and why I have it in my main system in lieu of the shit. Where was that? You know what? Where's the DAC? I see Texas. See, there's a TI chip right there, but where's the Verita? Another TI. Where the heck is the main DAC? I'd like to. There's two of them actually. I'd like to see that. I wonder if they're going to be buried under there. Well, I don't see. Hang on a second. Well, it took a while, but the DAC chip, the AK, what is it, 44 or whatever it is, the DAC chip, the Verita is right there. Very small chip compared to some of these other ones, but that's it right there. I can only find one. I know there are two in there. I think the other one's buried back up in there. So that's the heart. There it is. That's the heart of the whole thing. The heart and soul of this whole box is that little chip right there. I couldn't find the other one, but that's okay. Alright, I'm going to go ahead and get this thing back together again. Okay, here we go. So I got her all put back together again. And currently I am using my TEAC. Okay, so essentially I figured, well, you know, there's a bunch of different HD players you can download and use on your computer to play HD files and output them through your USB to the DAC. But I went ahead and chose to use the TEAC HR player because it interfaces nicely, of course, with their own DAC. And right now I'm playing. And what I really like about this player is that it's simple. You know, it basically, you get what you see right there. You can load up a playlist or an album, and here's what you get. You get the songs, and what I like about it is up top, it tells you the type of file you're using. Right now I'm using FLAC, and it'll tell you the bit depth, in this case 24-bit, and the sample rate, in this case 192K. So this is a truly high resolution file I'm playing right here. And if I want to, you know, if I want to pick something else, then I'll have to hit stop and load playlist. And right now I only have 4 bands on here, on this particular computer. And there they are. I'm trying to double click here and I'm not being very successful at it. Alright, so there's my Rush. And once again, it tells me I'm playing a FLAC file, this time a 96K sample rate, but a 24-bit depth. And also, if we again, I'm outputting the signal through USB into the USB Type B in the back, and right here it tells us it's PCM 96K. So let me turn this down and let's go through the menu system. And this system, playing files through TEAC's own high-resolution audio player, and by the way, how to download this player as well as the driver, the USB driver. And once you download the USB driver, when I go to configure, it will immediately recognize it, and there it is. That's the TEAC particular driver, and I've got a couple of options, and one of the options I've selected is to expand to RAM, which before it plays each song, it'll dump the song itself into RAM, and that prevents some playback. It's like a buffer that'll prevent interruptions in the playback. Okay, and I haven't had any interruptions in the playback, so it's perfect. Alright, so let's go through the menu options here. So first of all is our input selector, and there's really only two things we're going to be dealing with here. It's an input selector in the menu. So input selector is just what it says, okay? So I can go to coax, optical, the network, and the network is what I'd be using if I was streaming Spotify using the Spotify app on my tablet. Where's my tablet? I don't even know where the tablet is, but oh, there it is down there getting charged. And with the network, I'd be using the Cat5 is connected to the back, and I'd be streaming Spotify directly over the web, from the web. Bluetooth, which I use all the time. In this case, I hit Bluetooth and select device, and there's I've got different devices loaded, but there's the Galaxy tablet that I'm using. So that'll come up first because it was the last one that I was using. It connects fairly quickly, usually. There it is, it's ready, the tablet. USB in, that's what I'm using now. Coax, so back to USB. Okay, now let's look at the menu system. Let me get a song going here. Okay, so now we're streaming high res 96K 24-bit FLAC file. And let's look at some of the, we've looked at the inputs, let's look at some of the menu options. So I click menu. First thing it'll ask me is whether or not I want to upconvert the signal. And so I just click in on that button, and upconversion is off. And 4 times, 8 times, and it pauses, of course, during each because it's got to begin the upconversion process. So 8 times the sampling frequency, or it can go directly to DSD, upconversion to straight to DSD, or off. I tend to listen to it off. Here are the PCM filters. Here are those different filters I talked about earlier. So I'll select, there's the finite impulse response sharp, slow, slow delay, and back to off. The next is if you're using DSD, if you're upconverting or you have a native DSD file, you can select the cutoff filter, either 50K or 150K. Clock sync, that's if you're using an external clock from a source that has one. I'm not sure how that works. I don't have anything like that. Line out, so you can choose your outputs from here. So right now I'm running the RCAs down to the amp, but if I choose the XLR, there's one, there's another one, back to RCA. Now here's where you can turn on and off the volume control. Right now it's on fixed, so rotating this does nothing. It's like a line level output. But I can choose to plus 6 dB fixed, so it's a little bit louder, or I can choose variable, and if I choose variable, now I have a preamp. Go back, find that point. I just stick with fixed, and there's the dimmer. You can dim the display. 4 different settings, and it has an auto power save mode where if you leave this thing without a signal for, I don't know what it is, an hour or so, it'll automatically shut down. And net standby, on or off. I keep it on, and back to up convert. So there's all the menu options, and that's it. So some things from volume levels to up conversions, different up conversions, different filters. I don't know, I did something. I think the power cord was a little loose in the back because I just hooked it up. Different settings to play with and experiment with and see what you think sounds better. Interesting stuff. Anyway, okay, it's funny, I had to turn the camera off because, well, I just learned something. So it was, I guess when I was toying around with it, I had accidentally changed the dimmer setting. So here's what would happen. So let's go to dimmer, and I guess I accidentally had selected 0. And then what would happen is, after a certain period of time, you select, you know, doesn't matter what you select, the light would go out. At the time I didn't have any music playing, so boom. And I didn't have any music playing anyway, so the light would go out, and I was like, oh man, the thing cut out on me. And so I'd turn it off and turn it on and unplugged it and turn it on. It would do it every time. And what I didn't realize, I just learned this, is that that's dimmer setting 0, meaning after a certain period of time it's going to go out. So you can have this thing without lights at all. If for whatever reason you know, at nighttime or whatever, you don't want lights on. But it didn't actually go off. All you got to do is rotate a knob somewhere and it'll come back on. And then it'll go off again because dimmer is set. So let me go back. I always like to have the light on. I want to see the sample rate and that sort of thing. There's the dimmer. Let me turn that up to 3 and we'll leave it there, and then it'll stay on. Okay, so I just learned something because I never tinkered with that before. Alright, well anyway, enough of that. I've already kind of reviewed the sound of it in comparison with the benchmark and the shit and all that sort of thing in the previous series of videos about the DACs. I absolutely love the sound, but it's all the features that I like the most, and the looks of it and the build quality. So this will wrap up the video about the TEAC NT-503 revisited. Again, I thought it was worthy of revisiting because I didn't go through all the features and all the things, you know, I liked about it. I don't believe I did in one of the previous videos, and I get so many people asking me why, you know, if the shit won, why do I have the TEAC? Well, that's why. It's all the features, it's the connectivity, and of course it's the sound too. And it's been working flawlessly. No interruptions. Has never had a problem with whatever inputs I put into it. It plays it, you know, the Bluetooth, the optical, the coax, the USB, plays the files flawlessly. No issues whatsoever. And I know that some DACs out there have issues, have connectivity issues. So TEAC has been great, highly recommended. Again, thanks for watching. I thought I'd put together this video. Had an extra hour or so today to do this, and I'm still in the process of reviewing or listening to this amp down here, the Yamaha R9. That's a receiver, but I'm using it as an integrated amp. And I'll wrap that video up, part 4 of that one, real soon. But again, thanks for watching. Hope you enjoyed it. Ciao.